So, very good evening to all student members who are gathered here. I welcome you all for the module number 2 in chapter 4. So, today we are going to see about the various different types of surface finishing process in manufacturing. The very first one we are going to discuss about honing and lapping. What are the significant difference between honing and lapping? And at last, we will try to have the difference between those two processes in a much simpler extent. Now, individually, we will see both the process in surface finishing operation. Honing and lapping are considered to be precision abrasive finishing process, which helps to improve the surface finish as well as the material geometry of the workpiece. But there is a slight difference with respect to the abrasive delivery, application, and also typical use and functions. Honing uses bonded abrasive sticks, which is supposed to move in reciprocating motion in order to surface finish the internal area of bored parts, tubes, long cylindrical parts, etc. Whereas in contrast, lapping uses loose abrasive grain suspended in a fluid to finish the flat external surface of the part. Sometimes hollow internal diameter of the material can also be used to surface finish the components. So what are the primary application of honing? It is primarily used for surface finishing the internal hollow surface of cylindrical parts such as bores and tubes. Abrasive tool. So tool with multiple bonded abrasive stones or sticks will act as a tool for internal surface finishing operation motion of the tool movement. The tool moves with combined rotational and reciprocating motion against the workpiece. So here we can able to see the pictorial representation of the honing process as well as lapping. The purpose of the honing process is to enhance the geometry and create more precise fine cross-hatched surface finish on the internal diameter of the hole. So the application of lapping, the next subsequent operation, it is used for both internal and external flat surface to correct the minor imperfections in the material by achieving the precise dimension. So here the abrasive tool, it utilizes the loose abrasive particles suspended in a fluid that are pressed between the workpiece and a soft lap tool. The workpiece is typically pressed against a rotating lap plate, which can also rotate or reciprocate sometimes. The main purpose is to create a superior surface finish, perfect flatness in the material, and extremely close fit between the two mating components by removing the minimal material. What are the main key differences that are summarized between the two processes? In terms of abrasive, honing uses bonded abrasive, lapping uses loose abrasives. Workpiece, honing is used for only internal diameter of surface. Lapping can be used for both internal and external surface. Honing is a combined rotational and reciprocating motion. Lapping involves pressing the workpiece against a lap plate. Application: honing improves the geometric precision of hollow pore diameter of the cylindrical jobs. Lapping extremely produce a tight tolerance and perfect fit between the two assembly components. So these are some of the key contrasting features about the honing and lapping operation. Next surface finishing process, we are going to discuss about polishing and buffing. So what do you mean by polishing and buffing? So it is considered to be one of the surface finishing process that tries to smoothen out the material workpiece surface by using an abrasive on a rotating wheel. Polishing uses high-grade abrasives which is firmly attached to a surface like a belt or a disc to remove some of the deep scratches and imperfections by creating a lined brushed or lined finish. Buffing uses a softer rotating wheel with a fine, loose abrasive compound to remove the fine lines from polishing, resulting in a bright mirror-like luster. So let us understand the polishing process. So initially we have to do the surface preparation of the material. The surface is cleaned to remove any dirt, oil marks or contaminants that would interfere in between the process. Then applying the abrasive. A polishing tool such as an abrasive belt or a wheel with a disc is used. Then the high grade abrasive which is firmly fixed to the tool rotates against the workpiece. Then the abrasive grain remove the material to the level according to the surface finish to be expected by eliminating the deep scratches, pits and scale formation and produce a very smooth surface finish component. So in terms of buffing process, here the surface refinement can be done by polishing with the help of the prerequisites to ensure whether the surface is smooth enough for the final luster. Abrasive application, a loose fine grit abrasive compound is applied to the rotating flexible cloth wheel. Buffing action, the rotating cloth will act as a carrier for the compound, which will try to gently remove the fine lines from the polishing stage. So this process creates a final bright mirror-like surface finish, achieving a high luster. So what are the key differences between polishing and buffing? Polishing uses high-grade abrasive that is fixed to the surface of the wheel, while buffing uses a loose, lower-grade abrasive compound applied to the wheel. Polishing is a very harsh process with an abrasive disc or belt, while buffing is considered to be a more softer, flexible cloth wheel. Polishing creates a smooth but lined surface finish, whereas buffing removes those lines to achieve the high glossy mirror-like appearance. The next one we are going to discuss about grinding operation in surface finish. A grinding operation uses a rotating abrasive wheel to achieve smooth, precise and high accurate surface finish on the workpiece material, where the conventional machining is not suitable enough. The abrasive machining process, particularly say surface grinding, involves a workpiece moving under a spinning grinding wheel to remove small amount of material, resulting in a refined, flat, perfectly shaped surface with low surface roughness and tight dimensional tolerances. How grinding operation works? So with the help of the abrasive wheel, so the grinding wheel comprises of abrasive grains like aluminum oxide and silicon carbide. Both are held together by a bonding agent which act as a cutting tool. So abrasive wheel act as a cutting tool. And these are the materials which are used to make grinding abrasive wheel, aluminum oxide and silicon carbide. The rotating wheel, when it comes to contact with the workpiece surface, with each abrasive grain acting like a miniature cutting tool that will remove the small chips of material from the surface. The workpiece is held on a reciprocating or rotating table, moving precisely against the grinding wheel in order to ensure consistent and accurate material removal. Parallelly, the coolant is often used during the grinding to prevent overheating by improving the surface finish and flush away the removed material. What are the common types of grinding operation? Surface grinding, cylindrical grinding, and internal grinding. The most common type for flat surface involve a rotating beam and a reciprocating workpiece. It is used for finishing cylindrical and external surface. This type of grinding operation will achieve high surface finish on the inner part of the board components and hollow holes. So in conclusion, the surface finishing process is one of the most important operation which will try to enhance the component durability, functionality and appearance by modifying the surface texture through various methods like grinding, coating or even chemical treatments. A proper surface finish can able to improve the corrosion and wear resistance issues by reducing the mechanical friction between the moving parts. The choice of the surface finishing process mainly depends upon the high quality finish often require specialized and costlier techniques to achieve the desired specifications like smoothness or specific dimensions. So with this few information, I thank all the student members. So we have completed nearly 4 chapters in manufacturing process. The last one is polymer materials that we will discuss in the next subsequent lecture. That is chapter number 5. So thank you once again. Thank you all.